What's up, Tiger Math Team? My name's Anthony Karahalios. I'm here to answer any and all of your math questions. I'm glad you decided to do Math Team, and I'm here to help you out. So this is question 20 from ICTM 2007 AA 8-person junior senior team. And there's this track that is an ellipse shape and two people running, one at this speed and one at that speed. So the first thing you might think of is like using that general form of the ellipse. So you know that the center of the ellipse is at 7, negative 19. So that'll be the center. And then you know that the half of the axes are going to be the square roots of these numbers. So with the x side, this will be square root of 3, and the y side will be square root of 5. So yeah. Also, just to know about an ellipse, the area of an ellipse is pi times a times b. So you'll have pi times a is going to be like the square root of one of these, and then b is the square root of the other one in the denominator. But for this problem, you don't need to know about the area, you need to know about the perimeter because they're running around. Sadly, the perimeter is really difficult to obtain. There are some crazy approximations for it, or you can do an integral to get like this arc if you use a parameterized form of an ellipse, which is something like, something with sines and cosines, but you don't necessarily need that. If you think about it, you need to understand their relative rates. So, regardless of how big the track is, if one person's going a quarter of the other person's speed, and they both start here at point A, in one circle, one of them will make it this far, if he's running a quarter of the speed, and the other person will make it all the way around back to A, just knowing their relative speeds, if one's going a fourth of the speed of another one. So you'll know that they'll pass once, which is good. But then you need to think, when are they going to meet up at point A again? Well, this guy is going to be at point A every one time because we brought the ratio down to 1 1/4. And then the other person's going to need to go 4 times to make it back to that spot, right? Cool. So we have 7 1/3, which is 22 over 3, compared to 9 1/5, which is 46 over 5. So if you do a little ratio of those guys, you'll get 22 over 3 divided by that one, so 5 over 46, and that'll give you 11 times 5 over 3 times 23. You can't reduce any further there because those are all primes. So you'll get 55 over 69, which means that so back to this 1 1/4 situation, this is 1 and 55 over 69 now. So if you have your ellipse, each time one person goes around the entire way, the other person's going to make it 55/69ths of the way around the ellipse, regardless of how long the ellipse is, the perimeter. So knowing that, we need to think, when is he going to make it back to point A? So the one guy makes it back to point A every time, and the other one's making it 55/96 of the way every time. So if he's going to make it 55/96 of the way, the first time he's going to make it back to point A is in how many laps? So it's going to be 69 laps. So the first time he'll make it 55 69ths. The second time he'll make it 55 times 2 69ths. Like that's how far around he'll get, so he'll make it the whole way and then a little more. Then he'll keep going 55 times 3 over 69, etc. And then the time that it's going to get to a whole number, where you can get this 69 out of the denominator, is only if you're multiplying by 69. So back at 55 times 69 over 69, you'll have him going 55 whole laps around the track. Cool? And in that time, the other person should make it how many laps? 69 laps, right? Okay, cool. So, basically, you have that general problem in mind. And what you're going to think now is they're starting both at A. And you can kind of just count how many times they're going to cross each other in these 69 laps for one and 59 laps for another. So if one guy's starting at, this is like 0.0 or 69, you could think of it as. If you want to think of the track as being 69 units long, that works as well. So you're going to have him starting at 69, and the first time he runs, he's going to get to 55. You know, if he's running this way, he'll make it here, and the other person will make it all the way around the track. The next time, he's going to make it to 41. If he's at 55, the next time he's going to have to make it these 14 and then go the rest of his 55. So you can kind of think of it as a mod, like modular arithmetic. You'll have like 110 total, and then what's the remainder when you divide by 69? We'll give you 41. So if you keep doing that, the next time he'll be at 27, the next time he'll be at 13, the next time he'll be at 68, then 54, and 40, and 26. You're like subtracting by 14 each time. So this is like his spot each lap for the faster guy. This is where he's ending up relative to that starting position. So you have like 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 69. And we said that it's going to take him how many laps? We said 69 laps for the slow guy. So he's going to have to do 69 of these. So instead of writing it all out, because that's annoying, we're just going to kind of do a little like ... for each of these. So we have 5 numbers here, and we need to go to 69 total laps. So we're going to need, 5 times 13 columns to get to 65 and then go down to 69. So what you can do is this will go to 42. They're all decreasing by 1 each time in these nice little rows. So you'll get this, pretty much. And like 69's back when he's at point A, which is good. Yay. Nose. So, yeah, these are his positions after each lap, and now you have to think, okay, in all of these laps, how many times is he passing the person running in the opposite direction? Okay, so the first time they pass once, just because they're starting in the same spot, one makes it all the way around, and the other one will see him and then stop a little short. The next time, though, they're going to cross 2 times. If you have your little track, one of them's here, one of them's here, and this guy's running this way, this guy's running this way, they're going to pass right away. And then also, when he's getting back to his original spot, he's going to see him again. Yeah, maybe somewhere over here or something. So they're going to pass twice. So you're going to need a +2. So you need to think, in all of these different laps, are they going to pass once or twice, and why? So you can also think that in your ellipse, they're not going to pass twice if they're too close together. So I think we have it. If like this one's at like 2 and this one's at 0, then if you have them running in this direction and this direction, he's going to make it all the way around and see him, and he's going to make it to, they're going to pass somewhere over here, and then he's going to make it back to here, but this guy's not going to cross him. This guy's going to only make it over here. And that's going to happen when this guy doesn't make it back to 69. So he's not going to make it back to 69 if he's between 0 and 14, or 14 he'll make it exactly back right here. Yeah, so you know that he will pass him twice unless he's between 0 and 14. So for this row, you're only going to be passing once. So these are all plus ones from when he's at 13, 12, 11, 10, 9, all the way down to 1. And then you know that this last time, it's only going to be a plus 1 as well, because he's going to end up back at point A. So you have that he's crossing 13, 14, 15 times. He's crossing once, and then the rest of the times, there's 69 total, so 69 minus 15 is 54. He's going to cross twice. So this gives you 15 plus 108, which is 123 times that he's going to cross the other person. So I hope that made sense. If you have questions, feel free to ask. I can type out the solution or whatever, explain it more clearly, because this is a little bit ratchet. But yeah, there you go. Make sure you know all about ellipses. That's important in general, and knowing the area of an ellipse. But yeah, you didn't really need the perimeter in this problem. So make sure you're trying to be clever and think of witty ways to solve the problems that might just use a relative rate or something a little bit clever. There you go.